Most people think 200 miles per hour is fast, but today, we're looking at machines that don't just drive, they launch. From Swedish to British missiles, here are 10 vehicles that prove the future isn't coming. It's already here, sleek and fast. The Pagani Utopia looks like the car that does too much by not doing too much. At first glance, it's almost restrained. Smooth surfaces, clean arcs, no theatrical wings. But that calm shape does far more work than it lets on. Instead of relying on external aero tricks, Pagani channels airflow through the car, using internal ducts and two discrete active rear flaps to stabilize the chassis at speed. The payoff is a drag coefficient of 0.278 CD, which puts the Utopia closer to a low-flying aircraft than a road car, except this one is comfortable cruising past 200 miles per hour. Power comes from a 6.0-liter twin-turbo V12, built exclusively for Pagani by Mercedes-AMG. It delivers 864 horsepower and 1,100 Nm of torque. But the real story is how little mass it has to move. At just 1,280 kilograms, the Utopia carries less weight than many modern sports sedans. That creates a power-to-weight ratio of 676 horsepower per ton, a figure more commonly associated with fighter jets than street-legal machines. Unsurprisingly, it clears 0 to 62 miles per hour in 3.1 seconds. Then there's the transmission choice, which feels almost rebellious. While most hypercars hide behind dual-clutch gearboxes and hybrid buffers, the Utopia offers a 7-speed gated manual. Nearly 900 horsepower managed by human input alone. This is the car that is as fast on paper as it is on the soul. If the Pagani Utopia feels like a precision instrument, the Hennessy Venom F5 is speed stripped down to a single variable. Named after the most violent classification of tornado, the F5 exists for one reason: to push past 311 miles per hour and keep going. Everything about the car serves that goal. The carbon fiber body is tight and compact, not dramatic. Its priority is minimizing frontal area and turbulence, cutting through air the way a supersonic projectile cuts through the atmosphere. Even the butterfly doors open to reveal a yoke-style steering wheel. Less grand tour, more flight hardware. At the center of the chaos is an engine that borders on absurd. The 6.6-liter twin-turbo V8, nicknamed Fury, produces 1,817 horsepower and 1,193 pound-feet of torque. That alone would be headline material, but context is what makes it alarming. The Venom F5 weighs just 1,360 kilograms, roughly 1,000 pounds lighter than a Bugatti Chiron. That means every horsepower has less mass to drag forward, resulting in a power-to-weight ratio unmatched by any production road car. In practical terms, it reached 219 miles per hour in a standing half-mile, a distance where most supercars are still figuring out third gear. The engineering details read like motorsport fiction. The turbochargers are 3D printed in titanium to save weight and manage extreme heat. There's no hybrid system cushioning the delivery, no all-wheel drive algorithm stepping in to calm things down. Power goes to the rear wheels only, forcing the car to wrestle for traction while simultaneously fighting aerodynamic drag at triple-digit speeds. At full throttle, the limiting factor isn't the engine, it's physics. Driving a Venom F5 isn't about finesse. It's about committing to velocity in its rawest form, where speed isn't a feature, it's the mission. If the previous cars bend physics on asphalt, the BMW Dune Taxi ignores roads altogether. Built by BMW Middle East as a one-off experiment, this thing feels less like a car and more like a deployment vehicle. It's fully electric, aggressively overbuilt, and unapologetically strange. Visually, it sits somewhere between a Mars rover and an M-Division fever dream, wrapped in natural fiber, reinforced plastic panels that trade gloss for toughness. The exposed suspension alone tells you this machine expects violence. Inside, the cabin feels like a command module. Digital displays, a yoke-style steering wheel, and systems dedicated to managing torque at each wheel. But underneath that matte black exoskeleton is where things get wild. The Dune Taxi delivers 544 horsepower and an outrageous 1,000 Nm of torque, available instantly. That torque is fed through a drivetrain designed not for lap times, but for terrain that actively wants to stop you. Its party trick is suspension travel, a staggering 400 millimeters at each corner. For context, most performance SUVs operate with less than half of that. Watching it climb massive dunes feels wrong in the best way. There's no engine noise, no gear changes, just uninterrupted thrust as it claws upward, floating over crests that would swallow conventional off-roaders. To top that, the chassis is built from aerospace-grade steel tubing, engineered to survive jumps and landings that would fold a normal SUV in half. While every hypercar chases speed by slicing air, this thing weaponizes electricity to turn loose sand into a launch surface. If you want to see more engineering that defies the laws of nature, hit that subscribe button and join the flight crew. Regular hypercars feel mechanical, but the Rimac Nevera feels computational. It is the one hypercar that operates on a completely different logic, using 4 independent electric motors, 1 at each wheel, allowing it to control torque with microscopic precision. We're talking adjustments made hundreds of times per second, faster than any human input and quicker than most aircraft control systems. The shape matches the intent. Low, wide, and brutally efficient, the Nevera R leans fully into function-first aerodynamics. A fixed rear wing, massive diffusers, and carefully sculpted channels generate real downforce without visual theatrics. It looks less like a car designed to impress and more like one designed to survive extreme forces, which makes sense given what it does next. The numbers don't ease you in. They hit all at once. 1,914 horsepower, 2,360 Nm of torque. From a standstill, the Nevera reaches 60 miles per hour in 1.74 seconds, a figure so aggressive it out-accelerates gravity itself. But straight-line speed is only half the story. In one infamous run, the Nevera shattered 24 world records in a single day, including the brutal 0 to 400 to 0 kilometers per hour sprint in just 25.79 seconds. That means accelerating to nearly 250 miles per hour, then braking back to 0 before most supercars even finish building momentum. A huge part of that control comes from structure. The battery pack isn't just energy storage, it's a structural element of the carbon fiber monocoque, giving the Nevera exceptional rigidity to perform feats that other hypercars would never dream of. The Koenigsegg Jesko doesn't feel like a fast car so much as a loophole in the rulebook. Named after Christian von Koenigsegg's father, it represents Sweden's most unapologetic experiment in mechanical extremism. Visually, it looks less like a supercar and more like a land-based interceptor. The wraparound windshield gives the driver a near 180-degree field of view, closer to a fighter cockpit than a cabin, while the bodywork exists almost entirely to manage airflow under conditions most cars never experience. Aerodynamics is where the Jesko stops being polite. A towering active rear wing, massive diffusers, and carefully sculpted channels generate enormous downforce. Enough that at high speed, the car is effectively being pressed into the asphalt by several tons of force. Power comes from a 5.0-liter twin-turbo V8, and it's one of the most advanced combustion engines ever put in a road car. On E85 biofuel, it produces 1,600 horsepower and 1,500 Nm of torque, but the real magic is how quickly it responds. That's thanks in part to the world's lightest V8 crankshaft, weighing just 12.5 kilograms. Less rotating mass means the engine spins up with chainsaw urgency. Then there's the transmission. Koenigsegg's 9-speed light-speed transmission doesn't shift sequentially. It selects any gear to any gear instantly. 7th to 2nd, done. The Jesko's carbon fiber wheels are milled from a single piece, light enough to reduce unsprung mass, while strong enough to survive triple-digit forces trying to tear them apart. Inside, the tech keeps pace. The digital instrument cluster rotates with the steering wheel, ensuring critical data never leaves your line of sight, while twin touchscreen controls integrate seamlessly into the wheel itself. Driving a Jesko isn't about chasing speed. It's proving that with enough engineering discipline, even the edge of physics can be negotiated. Think of the Bugatti Tourbillon as a mechanical concerto on wheels. Named after the watch mechanism designed to defy gravity, this car turns that philosophy into pure asphalt reality. If the Jesko is a Swedish orbital strike, the Tourbillon is a horological missile, combining elegance, precision, and sheer velocity in one impossible package. Its design evolution honors the Type 57 SC Atlantic, with a sharp central spine and perfectly sculpted curves, while the new dihedral doors open like wings of a spaceship. Step inside, and the car doubles as a digital detox chamber. Giant touchscreens? Forget it. Instead, the Tourbillon celebrates analog engineering at its finest. Exposed gears and intricate mechanisms dominate the instrument cluster, while the steering wheel rotates around a fixed hub containing all vital readouts. Even at full lock, your view of the engine, speed, and RPMs is uninterrupted. Performance, absolute lunacy. Underneath the carbon fiber body sits a 8.3-liter naturally aspirated V16 paired with 3 electric motors, creating a combined 1,800 horsepower. That translates to a 0 to 100 kilometers per hour sprint in under 2 seconds and a top speed flirting with 248 miles per hour. The car doesn't just accelerate, it teleports through physics, yet maintains composure thanks to AI-designed, 3D printed suspension components that optimize strength and weight with millimeter precision. Everything in the Tourbillon feels intentional. From the subtle hum of its hybridized powertrain to the surgical feel of the steering, it balances mechanical artistry with ballistic capability. In the world of hypercars, the Bugatti Tourbillon definitely proves one thing. You can honor tradition, push the envelope, and still make your heart skip a beat, all in the same moment. Next up is the Singer 21C. This Los Angeles-built hypercar looks like a fighter jet collided with a sci-fi concept and came out fully road legal. Its spaceship persona starts with the cockpit. Tandem seating. One passenger sits directly behind the driver like a real-world jet trainer, minimizing frontal area and delivering a jaw-dropping 3.5 to 1 lift-to-drag ratio. Every curve, every panel was sculpted by generative AI and optimized for speed, while the structural bones are 3D printed, leaving nothing to chance. The 3D printed chassis isn't just light, it's perfectly engineered. Every gram is intentional, and any removal would compromise integrity. Combined with an inboard suspension system and carbon ceramic brakes, the 21C offers both ballistic acceleration and control that feels almost surgical. Underneath the sculpted bodywork is a hybrid heart engineered for aggression. A 2.88-liter twin-turbo V8 revs to 11,000 RPM, partnered with 2 electric motors on the front axle, producing a combined 1,250 horsepower. That's enough to launch the 21C from 0 to 60 miles per hour in 1.9 seconds, faster than most production cars can blink, and carry it to 250 plus miles per hour. This car isn't just fast in a straight line. Curves got nothing on it, and it's got lap records at Laguna Seca in COTA to prove this. Driving the Singer 21C is a study in extremes. High rev combustion paired with instant electric torque, AI-informed geometry, and human reaction. Say hello to the Zenvo Aurora, a Danish hypercar that looks like it was designed to intercept meteors. The design philosophy is less is more, leaving much of the carbon fiber monocoque exposed to the elements, making it look more like a skeleton of a starship than a traditional road car. Available in 2 distinct missions, the Track Focus Agile and the Road Focus Tour. The Aurora features a hot V-engine layout that channels heat through the tail section to mimic the heat signature of a superbike. At its core is the Mjolnir, a 6.6-liter quad-turbo V12 that screams to 9,800 RPM, producing 1,250 horsepower on its own. In the Tour configuration, it teams with 3 electric motors to unleash a total of 1,850 horsepower and 1,700 Nm of torque. That's enough to launch 0 to 62 miles per hour in 2.3 seconds and carry the Aurora to a top speed of 280 miles per hour. With a power-to-weight ratio of 1.17 horsepower per kilogram, this Danish missile doesn't just accelerate, it erupts. effortlessly bridging the line between mechanical art and ballistic performance. Inside, the Aurora keeps the futuristic analog charm alive. Rotating dials double as digital displays, switching between mechanical elegance and digital utility with a flick. Seats are affixed directly to the carbon fiber chassis, creating a pilot's cockpit experience where you feel every shift, every G-force, every nuance of motion. It's minimal, purposeful, and unrelentingly driver-focused. The McLaren Speedtail is the spiritual successor to the legendary F1 and the most aerodynamically efficient car ever to leave Woking. Its spaceship silhouette is unmistakable, stretching over 5.2 meters long, roughly the size of a full-size SUV, but with a height so low it barely reaches your waist. The body is a seamless teardrop of carbon fiber, featuring static front-wheel covers that stay still while the wheels spin to eliminate air turbulence. Even the side mirrors have been deleted, replaced by retractable cameras that hide into the bodywork when velocity mode is engaged to make the car as slippery as possible. Beneath the elongated rear clamshell is a hybrid powertrain producing a combined 1,036 horsepower. While its 0 to 60 miles per hour time is a brisk 2.5 seconds, the Speedtail is a missile designed for the long game. It can hit 186 miles per hour in just 12.8 seconds, nearly 4 seconds faster than a McLaren P1 and almost 10 seconds quicker than the original F1. Its top speed of 250 miles per hour makes it the fastest McLaren ever built. When you activate velocity mode, the car actually hunkers down by 35 millimeters, altering its geometry to slice through the air with a drag coefficient lower than almost any production car in history. Additional fun facts. This vehicle is a 3-seater where the driver sits dead center, just like a fighter pilot. To keep the weight at a lean 1,430 kilograms, McLaren used electrochromic glass that tints at the touch of a button, eliminating the need for heavy sun visors. Introducing the Lotus Evija, the first all-electric British hypercar. Its design is defined by porosity, the idea that air should flow through the car, not just around it, but its more spaceship-like features are the 2 massive Venturi tunnels at the rear, encircled by ribbons of red LED light that make them look like jet engine afterburners. These tunnels aren't just for show, they brutally inhale air to create massive downforce without the need for a traditional drag-heavy rear wing. This electric missile is powered by 4 electric motors producing a mind-numbing 2,011 horsepower and 1,704 Nm of torque, making it one of the most powerful production cars in existence. Its acceleration is violent. It rockets from 0 to 300 kilometers in under 9 seconds. To put that into perspective, most supercars are still struggling to hit 200 kilometers per hour in that time. While its top speed is electronically limited to 350 kilometers per hour, the way it reaches that limit feels like an instantaneous jump into hyperspace. Here's a fascinating sci-fi fact. The Evija is the first production car to use laser light technology for both high and low beams, providing incredible crystal-clear vision in total darkness. Inside, the driver is greeted by a floating wing-shaped center console and a rectangular steering wheel that feels more like a starfighter yoke than a car part. Because weight is the enemy of speed, the entire chassis is a single-piece carbon fiber monocoque that weighs a mere 129 kilograms. The Evija proves that the future of speed won't just be silent, it will be absolutely clinical. 10 machines, over 10,000 combined horsepower, and enough carbon fiber to build a fleet of actual satellites. If you had the keys to just one of these road-legal spaceships, which would you be taking on a ride? Let us know in the comments.